Let's look at an example. Okay, a cylindrical pressure vessel is a vessel contains fluid at a pressure of 5 MPa, and the cylinder, which has an outside diameter of 2,500 millimeter and a wall thickness of 20 millimeter, is fabricated from steel, and the E and Poisson ratio are both given. Then determine the increase in both the diameter and the length of the cylinder. Okay, I just listed the 6 equations we just derived right here. You can just select the correct equations to do the calculations. Okay, in this type of examples or calculation problems, if you are requested to determine the normal stress, so remember that you will have 2 of them, right, along the longitudinal direction and the hoop direction. There will be different values, and the hoop direction value will be 2 times that of the longitudinal direction value. And if you are requested to calculate the tau max, right, remember you have also 2 equations, right, on the outer surface and the inner surface, right, they will have a difference of half of the pressure. Right. But in this example, you are requested to calculate the length, the dimension change. So you just need to use these 2 equations to find out the strain values along the longitudinal direction and the hoop direction. Then use them to find out the deformations. Right. So let's see how can we do it. Okay. The known values. Let's summarize them. The diameter is 2,500 millimeter. And the thickness is 20 millimeter. So from this, we can note that the inner diameter is 2460. Right, so the radius will be 1 to 30. Right, then the P pressure is 5 MPa. And the E, 193 gigapascal, 193,000 MPa. And the Poisson ratio is given as 0.27. Then we can just calculate the strains, right, along these 2 directions. Right? The longitudinal direction first. The equation said it's a PD over 4TE 1 minus 2 Poisson ratio. Right? This will be 5 times 2460 over 4 times 20 times 193,000 times 1 minus 2 times 0.27. Right? So the results will be 366 microstrain. Then along the hoop direction, you have PD over 4TE times 2 minus Poisson ratio. Right, here will be 5 times 2460 over 4 times 20 times 193,000 2 minus 0.27. Then here you will get 1378 microstrain. Okay, then we can calculate the deformations. Now this the deformation. Let's see. Examine the increase in both of the diameter and the length of the cylinder. Okay, let's look at the length direction first. Okay, so that will be the delta along the longitudinal direction will be just epsilon longitudinal times the length, right? You have 366 micron micro strain times it's a 6 meter, okay? 6 meter, 6,000 millimeter. It'll be 2.2 millimeter. Okay, this is the length change of this vessel. Then how about the diameter? Okay, the diameter will be just we can use the hoop direction strain times d. Right, 1378 micron times d is 2500. Okay, you will get 3.44 millimeter. Okay, so why can we use the hoop direction strain to calculate the change in diameter? Why? It's just because, strictly speaking, the hoop direction strain equals delta perimeter over perimeter. Right? So this would be pi delta d over pi d, okay, equals delta d over d, right? So you can use the epsilon hoop to calculate the change in diameter.